Hello class, today what we're going to talk about is lines and segments that intersect circles. So we are finally moving on from polygons and triangles, and we're going to talk about circles. So here we go. Lots of things that intersect circles, stuff that go through circles, stuff that just touch circles. First, some of these everybody knows. For example, a radius. Radius is a segment whose endpoints are the center of the circle and a point on the circle. Radius. All the radiuses are the same no matter where they are. A chord, this is something you all may not have heard of. A chord is a segment whose endpoints are both on the circle. So it goes from one side of the circle across to the other side of the circle. That's a chord. A diameter is a special kind of chord. It's a chord that also goes through the center of the circle. Next, we have a secant. A secant is, instead of being a segment's a chord, a secant is a line that goes through 2 points of a circle. So the secant will contain the chord. Chord is part of a secant. Tangent is a line that touches the circle just once. All right? It's in the same plane as the circle, and it's going to touch the circle at exactly one point. That point is called the point of tangency. Now, something that's very, very important, this is not the same tangent as from trigonometry. We just finished up trigonometry and triangles and all this. We had tangent there. This is not the same tangent. This is something different. All right? The tangent line only touches the circle at one point. A tangent ray or tangent segments are also, if they touch it at only one point. All right? So we have a tangent segment AB, we have tangent ray BA. Those are, or tangent ray AB, depending on which way we're going. Okay. So what we want to do, tell whether the line, ray, or segment is described as a radius, a chord, a diameter, a secant, or a tangent of circle C. And this symbol right here, this is the abbreviation for circle C. Make sure you put the point in the middle. You got to have the center in that symbol there. Otherwise, it just looks like OC, which is different. Okay, so we're looking at segment AC. So here we go. We have segment AC. This is the radius. Center is on the end point is the center of the circle. The other end point is on the circle. So that's a radius. Segment AB goes from A through the center all the way to B and stops. So this is a chord. Right? However, it is a chord that contains the center, so it is also diameter. Segment ray DE. Ray DE goes here. It touches point B and keeps going. This is the only point it touches, so this is a tangent ray. And line AE. So we have line AE, goes all the way through the circle, goes inside the circle, comes back out. It's a line. So this is a secant. Right. This is so not too bad, pretty simple stuff. What I would like you to do, using that same circle, is describe AG and CB. And then give a name of some tangent or a tangent segment. So pause the video, answer those, and then come back. All right, let's see what you got. So AG and CB, chord and radius. AG is here. This is just a segment as endpoints on the circle, so it's chord. CB starts at point C, goes to point B, so it starts at the center, goes to the edge, so this is a radius. And tangents, there's several tangents. Well, there's only one tangent, which would be line DE. You could have called it line DB. You could have called ray EB, ray ED, any of those. A tangent segment, same thing, it's just instead of having arrows on the end, you have segments. Segment DB, segment DE, segment EB, all of those would work. All right. Now, coplanar circles. Coplanar means they are on the same plane, so they're both like this, right, on the same plane. If you have one over here, they're not coplanar. But we're just dealing with plane geometry. So coplanar circles might intersect, they might not. All right? You could either have 2 points of intersection like this, where they kind of overlap, You could have one point of intersection, either where they just barely touch each other, or where one is inside the other and they touch at one point right there. If that happens where you have just one point of intersection, those are called tangent circles. Just like you can have tangent line tangent to a circle, you can have a circle tangent to a circle. So you have tangent circles. Or you could have no intersections, like these two. They don't touch, they don't overlap, nothing like that. However, if you have non-intersecting circles that have the same center, those are called concentric. Con means together, and centric means center. So their centers are together at the same place. A line or a segment that is tangent to two different coplanar circles is called a common tangent. And you can have internal tangents and external tangents. An internal tangent is inside. It's in between the two circles. And the definition here says it intersects the segment that joins the center of the circles. That just means it's in between the two circles. An external tangent will not intersect the segment that joins the center. So that means it's outside the circles. We'll take a look at this. So how many common tangents could we have on these? Well, on A, we're going to draw these. So we could have 4. We could have a common tangents on the outside, so we have the blue or the externals. Outside the two circles. Red are internal common tangents. You notice they go in between the two circles, and they cross this segment that joins the circle, the centers of the circle. So circles over here on problem B, you're going to have 3 common tangents. 2 external tangents and 1 internal tangent. In this case, these are tangent circles, so it's just going to touch it like that. Tangent to both circles are the same place. And for C, we just have 2 common tangents, just on the outside, because we can't draw anything in between the circles because the circles overlap. There's no space in between the circles. Nowhere to go. All right. So what I want you to do is pause the video and draw these. Tell how many tangents are the internal or external. All right. Let's see how you did. There we go. So 3 had 2 internal, 2 external, just like this. Number 4 just had 1 external tangent right there. That's it. Can't draw any internals, can't draw anything else. That's all you got. And 5, these are concentric circles, and we can't draw anything tangent to both of them because to get to the inside circle, we'd have to go through the outside circle. So that's no good. Now, what we're going to talk about now are a couple of properties of tangent lines, tangent segments. Any line or segment that is tangent to a circle has to be perpendicular to a radius. Okay? Over here, if line M wasn't perpendicular to the radius, it would go inside the circle at least a little bit. So we still have 2 intersections. So it has to be perpendicular. It has to form a right angle right there. Also, if you have 2 external tangents two external tangent segments that have a common endpoint, then these segments will be congruent. Okay? So let's take a look at this. Question here. Is segment ST tangent to circle P? Well, to test this, if it is a tangent, that means that this has to be perpendicular. ST has to be perpendicular to TP, which means we've got a right triangle. So how do you tell if it's a right triangle? You use Pythagorean theorem. And so you plug this in. We've got 12 squared plus 35 squared equals 37 squared, because this is our hypotenuse. And that does, let's see, that does work. So these are tangent. All right, so let's take a look at this. A little bit more complicated. This one, it tells us point B is a point of tangency, which means segment AB is tangent to circle C. We need to find the radius of the circle. Again, if it's tangent, that means that these are perpendicular. So once again, I've got a right triangle. I'm looking for sides of this right triangle, so I'm going to use Pythagorean theorem again. That's what we've been using for years, right? So we're going to plug in Pythagorean theorem. hypotenuse is AC, so we have AC squared plus BC squared equals, plus AC squared equals BC squared plus AB squared. Plug in our measurements, so we've got R squared plus 80 squared, now, but the hypotenuse, notice, it's going to be R plus 50, because we don't know what this R is. Right? So we square all this to simplify it. So R squared is R squared, 80 squared is 6400, but R plus 50 squared is not R squared plus 50 squared. You have to FOIL it together. It's R plus 50 times R plus 50, which is R squared plus 100 squared, R plus 2500. And now we just solve this. So we're going to move the R squared over here because you want to get them both together. And let's move this over there. And hey, look, stuff cancels out. That's nice. All of our R squares go away, which just leaves us with a nice linear equation. Divide by 100, and R is 39. So the radius of this circle is 39 feet. Alright, so what I've got for you to finish this up, 3 problems. Pause the video, work these 3 out, then come back and check your answers. Alright, you're back. Let's see how you did. 6, 7, and 8. There we go. Hopefully this is what you got. If not, let's figure out why. So is this a tangent of circle C, DE? Well, if it is a tangent, then this is a right triangle, right? Because that's going to be a right angle. So we can use Pythagorean theorem. Now, what some of you may have done is use 3 squared plus 4 squared equals 2 squared. However, CE is not a length of 2. 2 is just from E to the circle. We also have to add this distance here. So the length of our hypotenuse is actually 3 plus 2. So we have that. Well, 3 plus 2 is 5, so that's 5 squared plus 9 equals 9 plus 16. And 25 does in fact equal 25. So yes, this works by Pythagorean theorem. Alright. Over here, this is a little bit more complicated. Again, we're going to use Pythagorean theorem because it tells us this is a tangent. So this must be 90 degrees. It's got to be perpendicular. So we're going to use Pythagorean theorem again. So we set that up. R plus 18 squared is our hypotenuse equals R squared plus 24 squared. So we square all that to simplify it down. Move everything to move the R squares to one side and 324 to this side. Subtract both sides by R squared. Subtract 324 from both sides. Divide by 36. R equals 7. Here, these two are both tangent to the circle. They have a common endpoint, which means these two segments have to be congruent. So x squared equals 9. And if x squared equals 9, take the square root of both sides. And remember that everything can has a positive or negative value. Every positive or negative square root. Always 2 numbers when you square root something. And that's it. Hopefully you found this useful. Most of it wasn't too difficult. And I will see you next time.